Hi, I'm Mrs. Burns, and welcome to the first lecture of our Chapter 10 unit on solving equations, which is essentially algebra. So do you remember right from the beginning of the year when we talked about integers? Well, we talked about the order of operations. So do you remember something called BEDMAS? So here this stands for brackets for B, E for exponents, division, multiplication, then addition, then subtraction. BEDMAS tells us the order from left to right here, the brackets being the most important, which to do first when you have an equation. So let's take an example here as a little review. If you have 2 plus 4 times 5 squared plus 1, what would you do first? Well, the first thing that I notice is that we have a set of brackets here and that we have a set of brackets here. So we have to do these two things first, the two red lines, before we can times them together. So let's do the two red lines first. 2 plus 4 is the only thing in this set of brackets, and that is easily 6. Then we have times. Now this set of brackets, we have to look at what's inside of them to decide what part to do first. Do I do the 5 plus 1 first, or do I do the 5 squared first? Well, this part, the E then says stands for exponents, so we have to do the 5 squared first. So we know that 5 squared is the same as 5 times 5, which is 25 plus 1. And we can further break this down. This is the same as 6 times, and if you finish off those sets of brackets, 25 plus 1 is 26, and 6 times 26 is 156. So there would be our final answer there. It's basically one of those wonderful skill testing questions, how you have to go from the different orders using the order of operations and not just doing all of them from left to right necessarily. Alright, some words to know for this chapter. We already talked about equations, and that's basically a statement with two expressions that have the same value separated by an equal sign. So for example, 5x equals 10. So in this case, 5x is one of the statements, one of the expressions, and 10 is the other expression. And they have the same value, so 5 times x has the same outcome or the same answer as 10. And this whole thing is called an equation. Alright, so we also have coefficients, and those are numbers used to multiply a variable. So a number used to multiply a variable, in this example 5x equals 10, our coefficient would be this number 5, and that's because our variable is x. Remember that a variable is a letter that we use to describe an unknown number or value, and so 5 times x is the coefficient because it is multiplying, or you could even have dividing, so we should add or dividing, used to multiply or divide a variable. Then a constant is also a number, but it's a number that's all by himself. So in this case of 5x equals 10, can you guess which one the constant is? If you guess 10, you are solid on the right track here. And we're also going to be saying using the expression opposite operation, and this is just using our understanding of math to create a value of 1 or 0 by applying the opposite sign to a number. For example, let's take a look at this table. So the opposite operation from addition is subtraction, and if you have 1 and then you minus 1, then your result, 1 minus 1, will be 0. The opposite of subtraction is addition. So if you have negative 5 plus 5, the result is 0, or even, yeah, I guess that would be a great example. And then multiplying, the opposite is dividing. And so when you, that looks weird, dividing, or division, then the result you'll get is a 1. So if you have a 5x that's multiplied, the 5 times the x, and we want to divide by 5 to get 1. Any number divided by itself is 1. And if you have division going on, then the opposite would be multiplication. And again, the result there is 1. So one big thing to note, you should put a big star by this, because whatever you do to one side of the equation, you must also do to the other side of the equal sign. So again, we really want to be fair to both sides, not doing something to one side but not to the other, because that will not work out in the end. So the big idea for this chapter, we want to basically isolate the variable. So what we want to do is change around, reposition the furniture here so that the variable, the letter that we're looking for, is all by itself on one side of the equal sign. So for example, we had 5x equals 10. We don't want that 5 attached to the x. We want him all by himself. So we know that the opposite of 5 times x would be division. So let's divide 5 by 5 to get 1. But whatever we do to one side, we have to do to the other side. Now we're going to have 1x equals 10 divided by 5. So 1x is the same as just saying x, and 10 divided by 5 is the same as saying 2. So here we have x equals 2, and we can double check by plugging it back in. 5 times 2 equals 10, 10 equals 10. Woohoo! That's how we check it. All right, so our variable in this case, I'll just circle it, our variable is the x here. That's the one that we are isolating all by himself. Let's try a few examples here. This one is pretty much the exact same except for we have 4. So we want to get rid of the 4 so that x is all by himself. So if we have 4 times x, then we should divide by 4 to get x all by himself, but whatever you do to one side, you have to do to the other side. So now 10 divided by 4 equals x. And if you plug in 10 divided by 4 into your calculator, or if you know it inside your head, you'll get 2.5 as your x value. So again, 4 times 2.5 should equal 10. Does it? Double check before you hand in your work. The next one, negative 5b equals 45. So we want to get this b all by himself. So what are we going to do? Well, right now he's times negative 5, so let's divide by the negative 5. So now you just have 1b, and that equals negative 45 divided by that 5. So b equals negative 45 divided by, oops, this is a negative 5. I already messed up there. So make sure you put negative 5. And we know that when the signs are both negative, or when the signs are basically the same, then you're going to have a positive answer. And we're going to have a positive answer of 9. And let's plug it in to double check. Negative 5 times 9 equals negative 45. Last example, d divided by 7 equals negative 6. Well, this is the same as saying d divided by 7 like that. We want to get the d all by himself, but right now he's stuck to a 7. What's the opposite of division? It's multiplying. So let's multiply both sides by 7, just like that. Now the d is all by himself because 7 divided by 7 is 1d. We don't have to write 1, we just know that there's a 1. And negative 6 times 7, they have opposite signs, a negative and a positive, so our answer is going to be negative, and 6 times 7 is 42. Let's double check. If you plug in negative 42 divided by 7, you should get negative 6. Well, I hope you're feeling comfortable with this little recap and this rearrangement of our numbers and values. Please reread over all of the definitions and all the words to know before coming to class next day.